Alright, so in this video we are going to be looking at dimensional analysis, okay? So we have an example here. It's 40 miles per hour is how many feet per second. So when you're given 40 miles per hour, we want to know how many feet per second this is equivalent to. Alright, so a good way to know how we're going to approach this is to create a fraction of what we're given. So we're given 40 miles per hour, and thus we can do like a ratio of these dimensional analysis pieces as far as miles per hour. Our goal is to end up with feet per second. Okay, so if we're going to end up with feet per second, ultimately that's going to be way over here as far as in our answer. Alright, so what we're going to learn is we're going to see what is it that we will be doing, multiplying, dividing, and so on and so forth, this beginning number in order to get to this answer of 58 2/3 feet per second. Alright, so we're going to give the given ratio or information as a ratio, which is what you see, and our goal is to cancel. We are trying to cancel any unwanted units. Okay, we're going to be multiplying by forms of 1. We have a lot of practice of this forms of 1. Here in just a bit you'll see what I'm talking about. So for example, you see this first jump, this first step here, we are trying to get rid of miles. So since I have miles on top, I know at the very end I want feet. So that means I have to find a way to get rid of miles, and I'm going to do that with a ratio. Okay, so I'll have, since I have miles on top, I want to create a ratio that will have miles on the bottom. Okay, because when we multiply, that is a form of 1 and the miles disappears. So when we do this ratio here, as far as what we're going to use to cancel out miles, we need to understand that 1 mile is equivalent to 5,280 feet. Now there are other forms of units of measure besides feet that's correlated with a mile, but we're going to use feet because 5,280 is easily and widely used. Alright, so 5,280, the miles do cancel, so if I wanted to, I could say, if I multiply these two fractions, my answer would be giving feet per hour. But since we don't want feet per hour, we need to keep going. Okay, so now at least we have feet in our numerator, which is what we wanted. We wanted feet in the numerator, so now we have to find another ratio that we're going to multiply. And our goal now is to get rid of this hours. So we don't want hours, we want seconds to remain in the final answer in the denominator. Okay, so that's why you see these hours here, this hour here in the denominator, and you see this hour here. It's a form of 1 cancellation because ultimately you have hours over hour, which cancels to a form of 1. Okay, so again, we have to come up with what is equivalent to 1 hour that eventually will get us to seconds, which is what we're wanting here at the very end in our denominator. Well, I could relate 1 hour to 60 minutes. So again, if I were to multiply that, the hours do cancel to a form of 1, and my current units of measure would be feet per minute. Okay, so we're just going to keep doing this over and over until we get feet per second. Notice our last ratio that we're going to multiply is 1 minute. We'll cancel with this minute, another form of 1. You have that minute over minute. Okay, and then we equate it to what is equal to 1 minute. We have the widely used 60 seconds. Okay, so now our result is finally in this units of measure that we wanted. We wanted this feet, let me highlight it in green. We wanted this feet here per second, which is my final answer as far as showing feet per second. Okay, so you do have to definitely write very neatly throughout this problem so that you can keep all your units of measure all intact and whatnot, but ultimately we cancel these units, this minute here, or mile in fact, and then you have the minutes here, so that you're left with feet per second, which is exactly what we want as our final answer. Okay, so then you just multiply all of the numerators straight across, so all of these numbers that are left that you used will multiply, and all the denominators can multiply out. Yes, you can reduce as you even go through with the numbers, but it's probably easiest just to multiply and then reduce these numbers here at the very end, which is what you see here in blue as far as me highlighting that. Let's try an example problem. Our first example problem is a leaky faucet in our kitchen wastes a cup of water every 10 minutes. How fast is the water leaking in gallons per day? So we want to say we have 1 cup every 10 minutes. So our units of measure so far are cup and minutes. And you can look at this as like amount is that cup, and then units of time are our other units of measure. Okay? We want to know ultimately, so we're going to do dimensional analysis, and we're trying to get this piece right here, this 1 cup per minute, to eventually result through a huge process. It will result in gallons per day. Okay, so our goal is to get from there all the way to gallons per day. So let's go ahead and write that out. I'll write it in red. Gallons per day. All right. So let's see how we do this. First of all, I have cups in the numerator, and my goal is to get gallons. So I need to find a way to cancel out cups. Okay? So if I look at this, and I know that 4 cups are in 1 quart, I can say 4 cups are equivalent to 1 quart. And when I multiply this, I know those cups will cancel. So right now my running answer is quarts per minute. Alright, so let me make it a little bit more obvious as far as this would cancel with that to a form of 1. Okay, so the quart, it still isn't what I wanted. I want this quart to say gallons. So I'm going to continue to multiply by dimensional analysis pieces until I get those gallons. I know from this given here that 1 gallon is equivalent to 4 quarts. Again, multiplying by this form of 1 where the quarts is in the numerator and denominator will cancel to that form of 1. Okay? So that my current running answer in units will be gallons per minute. Okay? Well, so far we have the gallons that we need. Okay? Our goal was to get gallons in the numerator, and check, that's what we have. So now, since we have gallons in the numerator, our new goal is to cancel a way to change these minutes to result into a day. Now let's multiply the time pieces. We know that 60 minutes are in 1 hour, and finally we know that 24 hours are in 1 day. Okay? So, let me go ahead and make a little bit of room there. That means this minute will cancel with this minute to a form of 1. These hours will cancel to a form of 1 with those hours. And I'm left with units of measure in days, just like I wanted them here at the very end. Remember, this was my goal, to get it eventually to say gallons per day. So I know that I have gallons per day. And all I have to do is just multiply all of these numbers as far as what I have. I have 1, 60, and 24. And then we have 10, 4, 4, 1, and 1. So the ones are negligible. We don't have to use those. But I can go ahead and go to my calculator, control divide, and create this big fraction. Let's multiply all the numerator pieces. We have 60 and 24. So 60 times 24. Whoops. And then I'm going to go ahead and go to, let me go in the numerator real quick. Then I'm going to go down and I'm going to look at all of the time, okay? Or all of the other numbers in the denominator. we have 10, we have 4 and 4, and those ones are negligible. So we can go ahead and put 10 times 4 times 4, and my result is 9. Okay, so a good habit to get into, I didn't quite do it just now, is to press Control Divide so that you get that nice pretty decimal. Let me change my settings to normal. I'm currently using UIL math settings, and now it's going to be just as you would see it, of 9. If there are more decimals, we always check. In this case, there are not any more decimals, and thus number-wise, our answer is going to be 9. Units-wise, it'll be 9 gallons per day. And please, what I want you to get in the habit of doing, since you will be doing it next year in AP classes and whatnot, with AP Calc, is I want you to do units of measure with a slanted line. Okay? If you have fractions that are numbers like 3/4, please do that with a horizontal line. But with units of measure, I want you to get accustomed to doing it with a diagonal. So 9 gallons per day would be the answer for the first one. Now, I'm going to show you something that I do want you to use, should you choose to, is I want you to know how to do the dimensional analysis also with the calculator to check. This will not replace what you need to know how to do by hand, because all of this will be partly part of the credit for a question that is like this, because you have to know how to do it also by hand. Alright, let's go ahead and look at the calculator. So, let me get a nice clear screen, and I will start with what they gave me. 1 cup every 10 minutes. So I'm going to do parentheses, Control Divide, and I'm going to do 1 cup, so 1 Control underscore, and it depends on how the calculator identifies cups. It could be C, it could be the entire thing spelled out. Okay, so some of the times you can use, so that determined cup, and it's going to be for 10 minutes. Okay, so 10 underscore, and if you just put M for minutes, it might interpret that as meters. So you have to do M-I-N. Alright, so then we'll close our parentheses, Control, press this little button here below the delete, and we want this nice black triangle right here that will convert and do the dimensional analysis for us. So parentheses, Control Divide, we want it to give us gallons per day. So we're going to say Control underscore gallons. G might be grams. Actually, G might be gravity right now. I think GM is grams. So learning that familiarization as far as the units of measure, that is part of discovery with the calculator. And last but not least, we're going to say per day. Let's see if this works. It may not work, it may work, but I want you to know that you can use this as a form of checking. And sure enough, it did. It converted it all and did all that work for us to give it a check of 9.0 gallons per day. And we can go up there and click just to make sure that there are more decimals, but that's how you do it as far as checking with the calculator. Alright, so let's go ahead and look at number 2. Okay, I'm going to show you that the calculator basically does all of this work here for us. Okay, it multiplies all those pieces and gets us from here to there, which if you simplify this will just give you 60 miles an hour. Now, you can write 60 miles an hour like the following, the way I'm doing right here, or you can write MPH. Either one is acceptable. Okay, just remember, if you choose to do it this way, I want a diagonal fraction. Alright, so as far as 44 feet per second, notice the trend. We have feet here. Whoops. They chose to get rid of seconds first, so that's why you see seconds over seconds, because those will cancel to 1. And we know that 60 seconds is every 1 minute. Okay, so right now my answer is feet per minute if I were to stop right now. But we don't stop because we want to go all the way to miles per hour. So now my goal is to get rid of minutes. There are 60 minutes to every 1 hour. So these minutes will cancel to a form of 1. And just the units of measure, please know that the 60 and the 1 don't cancel. It's just the units of measure that we're looking at right now. Okay? And then we can keep going. Okay? You see, the next thing is, since we did end up with hours on the bottom, which is what we were wanting, then the focus changes to now multiply by a ratio to get rid of those feet. Okay? Notice the feet are on the bottom because these feet are on top, which will cancel to a form of 1, 1 on top, 1 on bottom, cancel to a form of 1. And then you're left with the units of measure that you wanted in the numerator, which was miles. Therefore, you get miles per hour. Last but not least, remember, we do have to make sure that we look at these numbers, multiply them all out. The ones are negligible, and then 0.5 and 5,280, and it will result in a reduced number of 60. Okay? I would do this in the calculator, but you could always refer back to the first one. Feet will be FT. Seconds will most likely be SEC. If not, you would try just S for seconds. Okay? And then miles. Miles is not M, because that's meters. Miles would be MI, and hour would be HR. Okay. Look at number 3. An old-fashioned record player spins an album at a rate of 33 1/3 RPM. Now, this is very important. RPM are revolutions or turns, like completely 360-degree turns per minute. Okay, so from this right here, 33 1/3 RPM, we have to understand to write this to begin with. Okay, revolutions per minute. Convert this rate into degrees per second. Okay, I'm going to highlight in orange the progress of revolutions. Look, I have it in the numerator. I'm going to put it in the denominator so they cancel to a form of 1. Okay, so now I have 360 degrees in 1 revolution. This is very important. 1 revolution is going to be 360 degrees. Think of it like racing or running around a track. It's a circular track. It's a whole 360 degrees with 1 revolution. Okay, think of a wheel on a tire, if you will. 1 revolution is covering those 360 degrees. Or a tire on a wheel is what I meant to say. Anyway, so our goal is to get to degrees per second. Okay, we do have degrees now in the numerator, so we are good to go. We can stop with that. But we do, since we did cancel these revolutions, we right now have degrees per minute. And we don't want degrees per minute. We want degrees per second. So notice this last ratio here. The goal is to try to cancel this minute. So we have to find something that has a minute in the numerator and correlate it with what we're wanting to end with here at the end, which is seconds. 1 minute is 60 seconds. So therefore, those minute units will cancel to another form of 1, and we're left with units of minutes on the top, degrees on the top, and seconds on the bottom, which all you have to do then is grab these nice pretty numbers that are the coefficients of these units of measure and multiply straight across, like we did with the calculator, and see what it would reduce to, which in this case it would reduce to 200 degrees. Alright, so now we have 2 more problems. We have number 4 and we have number 5. Okay, we're going to use the dimensional analysis that we just learned, and we're going to see about how we're going to progress through these problems to answer the questions that are being asked. Let's go to number 4 first. Suppose a car wheel is 26 inches in diameter, okay? That means 26 inches all across this wheel, okay? Half of that would, of course, be the radius. If the tire completes 1 rotation, or otherwise 1 revolution, how far did the car travel? So let's say that we put some kind of marker here, and we traveled with the car where it came all the way back up. Well, what would happen is that whatever the distance is around this tire is going to be basically laid out. And that's the distance that is going to cover. So like half that distance, which is about here, would end up like this. Think about like cutting a tire, if you will, and as you drive, it just lays on the ground and sticks to the ground. This one revolution would show the distance that the car would travel with that one revolution. So we have C is equal to 2 pi r, okay? Or you could say the circumference is equal to pi times d. Either one is fine. So what we want to do is we want to know how far would it travel. So all we have to do is multiply either by saying the radius is 13 and multiply this. So we get 2 times pi times 13. Or we could just say the diameter is 26. So we multiply and get 26 pi. Either way, 26 pi is still the same. So let's go ahead and do this in our calculator and see what 3 decimals gives us. 26 pi. 26 pi. Control enter. And then go up and grab those 3 decimals. 681. So we're looking at 681 are the 3 decimal places. And 81 was the, so it's 81.681 inches is what this would lay out to be as far as the distance traveled. If the car is traveling at 60 miles an hour, okay, so we're going to start off with 60 miles per hour. How fast is the wheel spinning in revolutions per second? So now we're going to go backwards. Our goal is to get revolutions on top, okay? So we want revolutions on top and we want seconds on the bottom. That's what we ultimately want to get to, okay? So let's try to go ahead and find a way to use the first part of this as far as we know we can multiply, all right? We could multiply the fact that 5,280 feet is 1 mile. And the reason why I chose to do that is because this mile will now cancel with this mile. So feet per hour is what we're at right now. We want revolutions per second, okay? So what we can do here, since we know this is in inches from part A, we can keep going and change this feet. 1 foot, which will now cancel with this to a form of 1, is 12 inches. Okay? Now we have this inches that we're going to use part A, and we know that 1 revolution, let me go ahead and put this in red, 1 revolution equated to this 81.681 inches. These inches will now cancel, and my running answer, as far as in my numerator piece, my units of measure, is now what I wanted it to be as far as revolutions. Now this 81.68, just a reminder, if you choose to write the decimal places, please use 6 decimal places as you go throughout the problem. Way over here, when we're with our final answer, we'll round this to 3 decimal places. So whenever I put this into the calculator right here, let me highlight it in green, I'm going to use the answer, and I'll show you what I do there here in just a bit. I'm just going to go up there and grab it. That way I don't have to write too much. I can save a little bit more time. All right. So let's look at our units of time. We have hours. We want seconds. Okay? So if I'm going to convert this, I need to use 1 hour is 60 minutes. And the reason why I put hours on top is because it will cancel to a form of 1 with the hours over here that's on the bottom. So now my answer is in revolutions per minute. And last but not least, yes, you guessed it, we're going to say 1 minute is 60 seconds. So now this minute will reduce, cancel to a form of 1, and therefore I finally result in the denominator with the units of measure that I wanted the whole time. Now, 60, 5,280, 12, and then the rest are ones. And on the bottom, I have this that I'm going to save or grab from a saved answer, and then times 60 and 60. Let's go ahead and save us a little bit more time by saying we could cancel one of these 60s on the bottom with that 60 at the very beginning. If we wanted, we could even reduce this 12 with this 60, resulting it to reduce to 5 in the denominator. It's still going to give us the same answer. So right now I have 5 to 80 left in the numerator, and I have this 81.681 times 5 in the denominator. Let's see what kind of answer we get. Alright, so control clear. Let's go ahead and do control divide. We're going to do 5 to 80. And then come down here, and right here is where I want to grab that saved answer that I'm just going to, oops, let me show you how I'm going to do that. Okay, so let me show you how I'm going to do this. Because this was my last answer, you could do control answer, and it is the 81.7. And this will only work if your last answer was the line right above. Or what you can do, like on your keyboard at home, on your computer, you can press Control C, and then come down here and press Control V like those hotkeys. Multiply by 5 because that was the leftover reduced piece, and my answer will result in 12.9. Now again, we want to reduce this to 3 decimal places as a default. So let's see if more appear. 0.928. So 12.928 revolutions diagonal per second would be the answer right here for part B. Alright, so we're almost done. Let's go to do number 5. On the average, the Earth is 93 million miles away from the center of the Sun. Assuming that the Earth's orbit is circular, okay, we're going to estimate the number of miles our planet travels in one complete revolution around the Sun. Again, we know one revolution is 2 pi r, okay? And the reason why I'm choosing to do r instead of this pi d is because it's saying we're this far away, 93 million miles away from the Sun. So it's given us that r. So if I just multiply 93 million as the r value, and I'll multiply it with 2 pi, I will get my answer. Let me show you how you can do that. Okay, so 93 million, 93, whoops, let me come down here, 93 million, 1, 2, 3, 4, 5, 6, we're going to multiply it with 2 pi, and then control answer. And you see this weird notation. If you don't know what this E means, this E is like saying 5.84 times 10 to the 8th power. So that E is this piece right here, the times 10. If you wanted to, you could have done that way over here when we were looking at inputting 93 million, okay? But you have to think of 93 million as 9.30, and then look, 1, 2, 3, 4, 5, 6, 7. So that would be E, and that would be 7, okay? And that's just that scientific notation. So if I chose to, right here, if I chose to say 9.3, right, so 9.3, you can't put the 0. Here's that double E is like saying times 10 to the power of 7. If we multiplied it by 2 pi, this is just another way of using the calculator, you would get the same exact answer, that 5.84 times 10 to the 8th. Well, we want the exact answer, so we're going to put this all the way in and go in and get the decimal places, so there and there. So you get 584,336,230. We're going to round to the nearest complete mile of 4. Okay. Now let's go back to our flip chart right here, and we're going to write the answer. Okay. Now I know it didn't say for us to round, so we should by default round to 3. So I'm going to go ahead and do that. 584,336,230. 6,234 point, remember those 3 decimal places, 568. 0.568. 568 if we round, 567 if we just chop it off and truncate it. And this will be miles. Last but not least, the complete revolution around the sun takes 1 year. How fast is the Earth moving in feet per second? Okay, so we're going to put our answer here of the 584,336, 234 miles. And yes, we would just borrow that answer for 1 revolution. And then we'd multiply 5,280 feet would give us the 1 mile. Those miles would cancel. And then we would keep going because we want feet per second. So our feet at least is done. Our numerator piece is done. So now the goal is trying to get this revolution to say seconds. So here we go. 1 revolution is 365 days. Okay, so revolution's gone. Now our answer is in feet per day. And then we just keep going. We know 1 day is 24 hours. There go the days. Now my language is in feet per hour. Remember, we want feet per second. And then we're just going to keep going. 1 hour is 60 minutes. Last but not least, we'll multiply with 1 minute is 60 seconds. And if you did that just like we've done all the other ones, we get, let's go to round this one just for practice, 97,834 feet diagonal per second. This is how far, think about that, 97,834 feet every second. That's how fast the Earth is moving in orbit as far as in feet per second. All right, that's it.